Okay, so let's first look at transforming data for polynomials. And so here we may start with as much as, x1, we'll just go with two variables just to get the idea, x2 and y. Okay, so we have these variables, and in this case all we need to do is decide what we think we want our model to look like. And so, for instance, in a couple of variables we may have y equal an a1 x1 and plus an a2 x1 squared, okay, something like that, plus maybe a b1 x2 plus a b2 x2 squared. So we will just need to make columns for those, and but even we can have mixed terms, so plus, say, a c1, which is maybe x1 x2, and interaction terms is what those tend to be called in the modeling biz. That x1 and x2 could interact, and we could add cubes and so forth. So but to do this we just need to add those columns. So we'll have an x1 column, and probably there's our x2 column, but we also have an x1 squared column where we'll just have to compute x1 squared, an x2 squared column. We would have an x1 x2 column where so as we look at our data, if this was a 3 and this were an 8, something like that, then this would get populated with 9, this would get populated with 64, this would get populated with 24, and was that it? Just those 5 variables. And so we would have those columns of data along with y, whatever that was, and we would do that all the way down, and we would simply give that to our multiple regression algorithm wherever we're using it, and whether it's Desmos or Excel or something like that, and we can then look at the answer once we get it, look at our coefficients for each of those, and then use our adjusted r squared and so forth to try to work out what we want or don't want from these data. Okay, so that's transforming data for polynomials.